Now, after all these general things, basically we come across Coulomb's law of electrical force in electrostatics. It is one of the very important law. This states that like charges repel and unlike charges attract. But the statement is not valid inside the nucleus. The Coulomb's law of electrical force is not perfectly valid for nucleus. The point to remember is that order of nuclear radius, not the value, order. Order of nuclear radius is 1 Fermi, 10 to the power minus 15 meter or 10 to the power minus 13 centimeter. Fermi can also be written as femtometer. Nucleus is at least constituted of protons, that is hydrogen nucleus, but other nuclei other than hydrogen nucleus, all other nuclei are constituted of protons, that is 1h1 and neutrons, 0 and 1. The very important masses, the very approximate masses of 1h1 and 0 and 1 are specified in AMU, that is 1.008665 and 1.007825. Both numbers are in atomic mass units. However, the mass variation starts at third place of decimal. Therefore, for calculations, nuclear masses must be taken at least up to 3 places of decimal and more accurately up to 6 places of decimal. Atomic radii are generally of the order of 10 to the power minus 10 meters. That is 1 angstrom unit. The central part of atom is nucleus and extra nuclear part is orbit. Orbit is a definite path of electron, but orbital is a high probability zone of electron. Atomic number is represented by Z. Z means either the number of protons within the nucleus or number of electrons in the extra nuclear part. P stands for number of protons constituting the nucleus and E stands for number of electrons in the extra nuclear part. Atomic mass number means nucleon number and that is represented by A. Approximate mass of electron is 9.1 10 to the power minus 28 grams or 9.1 10 to the power minus 31 kilograms. The range of electric field of nucleus that varies only from the central part to the orbit. So it is varying from 10 to the power minus 15 meters to 10 to the power minus 10 meters. That is 1 Fermi to 1 angstrom unit. The ratio of the order of sizes of the nucleus and atom are generally 10 to the power minus 15 divided by 10 to the power minus 10 and that becomes 10 to the power minus 5. The electrical forces among the static charges are conservative and same is true for gravitational forces. The Coulomb forces are charge dependent and gravitational forces are mass dependent. Now, nucleus is a point mass and a point sphere. Similarly, atom is also a point mass and a point sphere. So, if it is a sphere, the volume is given by 4 over 3 pi r cube. The order of volume of nucleus can be taken as 10 to the power minus 45 meter cube and the order of volume of atom is taken as 10 to the power minus 30 meter cube. If we take the ratio of the volume of the nucleus and the volume of the atom, it becomes 10 to the power 15. Exception to the hydrogen nucleus, all other nuclei are having 3 types of grouping. Exception to hydrogen nucleus. In all other nuclei, we can arrange nucleons in the groups like proton-proton group, they are positively charged group, the neutron-neutron group having no charges, and the other is proton-neutron group having one is positive charge and other is neutral. The forces among the nucleon pairs are known as nuclear forces. They are short-range forces. Their range is nearly 0.5 Fermi to 3.8 Fermi. These forces are charge-independent forces but distance-dependent forces. However, they are originated due to spin-off nucleons. If R is greater than or equal to 0.5 Fermi up to 3.8 Fermi or approximately R is 1 Fermi to 4 Fermi, the nuclear forces will be attractive. That is, nucleons will have tendency to attract. But if R is less than 0.5 Fermi, then forces among the nucleons will be repulsive and the nucleon pairs will begin to repel. If R is greater than 4 Fermi, then nuclear forces will vanish, they will drop to zero. R means the distance among the nucleon pairs. The range of nuclear force is 1 Fermi to 4 Fermi, and from the spectrum of nucleus it is found that net forces among the nucleon pairs are attractive. The nucleons have masses, therefore small gravitational force exists among the nucleons because gravitational forces are mass dependent forces. It is further found that nuclear forces are stronger than electrical and electrical forces are stronger than gravitational. By all calculations and by the spectrum analysis of the nucleus, it is found that nuclear forces are stronger than electrical forces by 35 to 100 times, and nuclear forces are stronger than gravitational forces by 10 to the power 34 times to about 10 to the power 39 times. The mathematical statement of the Coulomb's law is given like force is dependent on the product of charges if the distance r between them is constant and the medium in which the charges are placed are constant. The another law is F is inversely proportional to r square, where the product of charges and the medium must be constant. F is dependent on medium if r is constant, that is distance between the charges, and the product of charges is constant. So F is proportional to Q1, Q2 by R square, or F is equal to A into Q1, Q2 by R square. A stands for electrical constant of the medium. That is, F is equal to A into Q1, Q2 by R square. So for A, we can substitute 1 over 4 pi epsilon naught epsilon R or 1 over 4 pi epsilon. So force is estimated by the given function, that is 1 over 4 pi epsilon Q1 Q2 by R square. For air or vacuum or free space, epsilon R is 1 with respect to epsilon naught, and epsilon naught is known to us, 8.854 10 to the power minus 12 Coulomb square per Newton meter square. And this value can also be written in farad per meter. Coulomb's law for free space can be taken as force in air medium is 1 by 4 pi epsilon naught Q1 Q2 by R square, because epsilon R is 1. Force in air medium will be K Q1 Q2 by R square, and K is 1 over 4 pi epsilon naught. K is called the electrical constant of free space, and its value is 9 into 10 to the power 9 Newton meter square per Coulomb square. If we put up all these dimensions, we'll cancel the units and force can be calculated in newtons. Now, after this, we can define what is 1 Coulomb charge. It can be defined by assuming that let Q1 and Q2 be 1 Coulomb and the separation of the two charges be 1 meter in air or vacuum. Then the force will be calculated as 9 into 10 to the power 9 newtons. The unit positive charge of 1 Coulomb charge is that charge which repel another equivalent similar charge of 1 Coulomb with force of 9 into 10 to the power 9 Newton when their separation is 1 meter in air or vacuum. The magnitude of electrical force among proton pairs is nearly 230.4 newtons, and the magnitude of gravitational force among the nucleon pairs is nearly 1.7 into 10 to the power minus 34 newtons. Electrical force is stronger than electrical force by 35 to 100 times, and nuclear force is equal to 35 times of electrical force, maximum 100 times of electrical force. Nuclear force is 10 to the power 34 times the gravitational force and maximum 10 to the power 39 times the gravitational force. Electrical force can be calculated by formula K Q1 Q2 by R square and gravitational force by F is equal to G M1 M2 by R square. In both the equations, Q1 and Q2 will be the charges of proton. Suppose that we are interested to find the force between the two protons within the nucleus. So Q1 and Q2 are replaced by QP, whereas in the formula of gravitation, M1 and M2 are replaced by MP and Mn. MP means the mass of proton and Mn means the mass of neutron. If R is taken as 1 Fermi, 10 to the power minus 15 meters, G is 6.67 into 10 to the power minus 11 MKS units, and K is 9 into 10 to the power 9 Newton meter square per Coulomb square.